Okay, we are back and we're still working on the Unity Dispatcher for our thread system. Lee, please continue.
Oh, come on. I wanted to change up on this video. I was going to let you do the coding.
Well, and I thought about it. I don't want to make you look bad. You've done such great work up to this point that I don't really need to undermine you that horribly for everyone to see. So, no, please, just go ahead for your
All
sake.
right. For my sake.
Yeah.
But I just wanted to share. I thought you were just kind of feeling left out.
No, it's all good. It's all good.
Oh, all right. All right. If you're
Yeah,
sure.
I'm more amused than anything else. So please continue.
Okay. Well, no problem. We're going to create a new class, as you can see. This one's going to be called UnityDispatcher. So go ahead and create it. A little bit of cleanup. Someday I'm going to go ahead and write my own templates,
Probably
so I don't
not.
have to do this each time. But I always say that, never get
Yeah,
around to it.
probably won't ever happen.
Yeah. All right. So this will be a public static because I only ever want one dispatcher in the system. I don't want to have multiples of this guy. So he's going to be static. He's going to rely on our priority queue to hold the information that he needs to execute. So we'll go ahead and create a private static read-only priority queue. And this is going to be a priority queue of type iUnityDispatch. Go ahead and add that to my using statements. Sometimes I really, really like ReSharper, as opposed to the times where I really, really hate it. But in that case, that's one of the times I like it. All right, let's go ahead and skeleton in the methods that we're going to do, and then we'll come back and put them in.
Okay.
So we're going to make a static constructor. So a static constructor for UnityDispatcher. Seems how it's static. We're going to make a public static update that's going to have a void return type. And we're going to need a public static QUEUE.
Great word.
Yeah, always found it an interesting one. QUnity calls. Do I want to call it calls now? Dispatch. Changing on the fly again. All right, now our QUnityDispatch is going to need a couple of things sent into it, and it also needs to return something. So it's going to return a UnityDispatch. And why does it not want to return that the way it should? Maybe when I fill this in. Public static UnityDispatch. Did I misspell something?
I mean, that'd be the first thing I'd guess. But...
Yeah, that's what I was thinking. UnityDispatch. It's public. Nope. All right. Type name unexpected, but namespace found. That's interesting. Let me finish writing this out and I'll sort that out. All right, so it takes two arguments, an action, which I'm going to call action. Go ahead and add that to. And then we need a priority. So QPriority. And we'll call this priority. And let's see. Return null for now. All right, so everything's in place, but it's not happy with this for some reason. Now, did I miss something else? I don't know. We might want to pause it for a sec.
Okay, and I'm
So,
pausing now. We're back.
okay, so everyone that's been screaming for the last couple of minutes what the problem is, I finally figured it out. I've got my folder name, dispatch. I'm going to make that plural, dispatches.
Okay.
And then from here, I'll go into UnityDispatch, change the namespace. And go to iUnity, change the namespace. So that makes everybody happy there. And then we can add this, which makes that happy. Things get confused when you name a class and the namespace the same name. It doesn't know which one you mean.
Yeah.
So, it happens.
No worries.
Okay, so back to work. All right. Now, our static constructor only needs to do one thing, and that is going to initialize our queue. So we're going to take queue, we're going to set it equal to a new priority queue. So that takes care of that. Now, let's go ahead and look at dealing with our dispatches when we set them up. We're going to wrap this up in a try catch like we did with the thread pool. So the pattern that we're looking at is going to be similar to when we were queuing up our user work item.
Mm-hmm.
Here where we're using a func, we're just using an action, but the way we're setting it up is going to be very similar to this. So go and try. We're going to say var dispatch equals a new Unity dispatch. And we're going to pass it in an action. So that's our action. From here, we're going to queue it. So queue.enqueue, pass in our dispatch, give it a priority, which we're taking in as argument, and then we're going to return that dispatch. Reason we want to return it is because there's information in that dispatch about causing the thread to wait and how long it needs to wait, as well as information of when that dispatch has been executed and completed. So we want to be able to pass it back, so if the calling worker thread wants to hold on to it so it can look up that information later, it has the ability to. And if we didn't pass that dispatch back, then we'd have no way of figuring out whether or not it was done from that worker thread. If for some reason we fail, we'll just return null. And I can kill this return null. Now, update. This can be as simple as saying queue.dequeue, taking the results out of it, and then running it. This would run one item every update. So every frame you would get one item pulled out of the queue, executed, and sent back. That is a little bit too simplistic and not the most efficient way I can think of doing it. There's several different ways of doing it, but or of scheduling it. But if it's a very simple Unity API call, let's say you just want to look up the position at a transform or set the name of an object, that's not going to take a lot of time. So why waste an entire frame just to do that one instruction when we could potentially do several instructions? But conversely, there is the potential that the action that we send in isn't just a single action. It may be an entire method full of Unity API instructions. And the total time that it takes to run that one action is longer than we want to allocate for an update. So we may end up with an update cycle in here where we can only execute one of the dispatches. There might be a case where we could do 20, 30, or 40 of them. So we want to maximize our available time per frame to run as much of the stuff that is inside of this queue as we possibly can. So to do that, I'm going to use a variable called start time that is going to take the datetime.now value and save it. I'm going to set up a second variable called end time, and initially I'm going to set it to be equal to start time, because when we start off, start and end time are going to be the same time.
Okay.
I'm also going to then set up a while loop. That while loop is going to, for now, just say true, but it's going to be a little bit more complicated here in a sec. So in this case, if we were to run it now, it would continue to execute until everything in the queue was depleted, and then it would still try to execute, which is not a very good thing. So we need to modify our condition. We're going to say while queue.count is greater than 0. So that's the first obvious one. The only time you want to keep running through this loop is while we still have things in the queue to execute. And our end time minus our start time so we take end and subtract start time, we convert that into total seconds. Total seconds will give me fractional seconds, which is what I'm going to rely on for this. And I'm going to say while total seconds is less than the time dot delta time. Whoop, that didn't work quite the way I wanted it to. Time. We'll add Unity Engine. So time delta time times 0.01f. All right. Now where and why am I using delta time times 0.01? Delta time is the time that it took between the last frame or the render the last frame to this point in time. So in effect, it's the time, the total time it's taking to render a frame, this frame currently. By multiplying it by 0.01, I'm allotting 1/100th of that frame time to be allocated to run actions inside of this particular update. So I'm basically saying, hey, up to 1/100th of the time it takes to do a frame, run as much as you possibly can. But the moment you go over that, you need to stop. Okay. So if I get one action that takes, 5 frames to render, this is still going to execute and run, and it will take what it considers 5 frames, which will slow down our frame rate, which is one of the reasons why the optimization tricks that Unity touts so much is try not to do anything inside of an update call that would take longer than a single frame to run. Mm-hmm. But conversely, if I'm running actions that are taking nanoseconds or just very minute amounts of time, I could conceivably execute 5, 10, 15 of those in that amount of time. Yeah. So this is just going to try to maximize it. The reason I chose 1/100th of a frame was it was just a nice round number, and it's still it's only taking up 1% of the frame render time to run these actions, while still allowing potentially up to 99% of the remaining frame time to do other things. Because this isn't the only system that's going to be running on this computer. So we've got to still allow time for other things to be able to run. Now I'm going to set up a var count equals 0. And then from here, inside of our loop, I'm going to increment that count. And then I'm going to say if our count is greater than 0, go ahead and debug dot log, and we're going to log out the count. This code is just simply so we can demonstrate that this is working. So what it'll do is it's going to increment how many times per frame it's executed one of these instructions. Write that out. And the reason I'm doing this condition is I don't want the console to run up with a whole bunch of entries of 0.
Okay.
Excuse me.
Mm-hmm.
And let me go ahead and just clarify what we're getting in our console. All right, so we've got all that going. We are, I think, built successfully. I think that's all the code that we need for the 2 parts of the system.
Okay.
So what we'll do is we'll wrap it up here. In the next video, we'll go ahead and set it up and test it.
All right. So that'll wrap things up here. Thank you very much for watching.